fail to work any longer. All right, so we need 3 definitions. We need primary consumers, herbivores, and we had a key fact in there, something that happens to the energy. Okay, here's herbivores. I knew that from yesterday. To consume means to eat something and absorb the nutrients. And herbivores are primary consumers. So we're going to go back. Oh, and our last thing. Some of the energy is lost. So every time energy goes from one organism to another, some energy is lost. It takes energy to digest the food. It takes energy to catch the food, to chew the food. The primary consumers are herbivores. All right, energy is transferred again in the ecosystem's flow from primary to secondary. Carnivores or meat eaters act as secondary consumers. Lions, tigers, and polar bears are carnivorous. They eat the meat after a hunt. When tigers eat their prey's meat, they go on to digest it and use the energy for their own. Like the herbivores in the previous section of the energy flow, carnivores also give off energy when their bodies warm up from. Unfortunately for the carnivorous secondary consumers, they too will eventually find themselves targeted by other members of the ecosystem, tertiary. Secondary consumers are carnivorous predators, meaning they hunt down other animals and kill them for food. However, these animals are not at the very of the food. They too can be hunted and utilized as a tertiary consumers or predators who lie at the top of the food. Human beings are the most obvious example of a tertiary consumer. Unlike the secondary consumers, tertiary consumers are not normally preyed upon by other members of an ecosystem. All right, so we're going to come back and highlight. Meat eaters are carnivores, and their secondary consumers is also the omnivores. We have 2 other words, predator and prey. I don't think it gives us a definition for those. Tertiary consumers are ones at the top of the food chain. All right, so we're going to come back to our pyramid. So all of your primary consumers end up being prey for other organisms. Your secondary consumers are carnivores and omnivores that eat primary consumers. But these can be both predators and prey. Something eats them, but they also eat these. And your top ones are your top carnivores. We call these apex predators. Humans, tigers, sharks. Nothing eats them, per se. Well, actually, sharks fit in there. Maybe a killer whale. All right, our last one. Like the primary and secondary consumers, the tertiary consumers give off body heat, the energy that is released into even if consumers or producers aren't hunted or eaten, all living things eventually, when they do, they decompose. Bacteria and fungi attach themselves to a dead producer or consumer and begin to break down the matter of the releasing nutrients into the soil. These nutrients are then used to give life to new so that new energy from the sun can flow through the eco-pyramid. All right, so we're going to highlight when they die, they decompose, and they break down. All right, so we're going to go back to our diagram. So remember, at each stage, energy is lost. So we have producers, then we have our consumers, and there's 3 levels of them: primary, secondary, and tertiary. So these are prey, and they're also your herbivores. Things that get eaten and things that eat producers. Then we have carnivores, small carnivores like a cat, and omnivores like a raccoon. And they are going to be both predator and prey. And then we have our top consumers, carnivores. And these are only predators. And some people call this an apex predator, if you want the fancy word for it. All right, so how are these similar and different? Are there things that are shown in all 3? How is this one related to this one? And why does this one have a triangular shape? What is this showing? I'm not going to answer those questions because those are the questions in your packet. So we're going to go ahead and mark our ERQs, and then we're going to do our nitrogen cycle. Explain, this is your assessment for today, so take a picture and send to JoJo, or do a Google document, or you can write it in your packet. Explain the sequence of steps of the nitrogen cycle. And this is one of the hardest ones, so you're probably going to need multiple ideas. Compare and contrast. So we have 2 verbs, an eco-pyramid with a food web. And what are synonyms for compare and contrast? Same and different. So you need at least 2 ideas. All right, so go ahead and get your a new diagram page out. I ran out of space. And this is Wednesday, April 13th, nitrogen cycle. And the video really explains this really well. Okay, so nitrogen cycle, we need a couple of things. First off, we need a plant. One, pick a plant, and then pick a tree. And you need to draw roots. All right, so in the roots are bacteria. These are as if they're really big. Plant, roots, bacteria. So the bacteria, there's nitrogen hiding in the soil, and there's also nitrogen in the air. And nitrogen is so small, you can't see it. I'll make a little key over here. And when the bacteria in the roots of the plants break something down or decompose it, they return nitrogen to the soil and there's another really cool part of the nitrogen cycle. This is a cloud. When there's lightning, the lightning also puts nitrogen in the air when it flashes in the atmosphere. All right, and we need one more thing. So the bacteria and the roots, when they break down dead things, it puts nitrogen in the soil. Part of that process is with lightning and nitrogen in the clouds. And why do we care about this? Because baby plants use this nitrogen to grow. That's what makes it a cycle. You have to have something going around. And in fact, if you look at fertilizers, the number one ingredient in a fertilizer to help a plant grow is nitrogen. All right, so we're going to stop here for today. Make sure that you have watched your brain pop, possibly played your game, made your cycles with me in a picture format. Yours can look like mine or look like your own. But definitely the process of writing this down helps. And then make sure you also complete your ERQ. So you're going to turn your diagram into words. And then you're going to compare and contrast the two different ways that energy is shown. All right, have a great afternoon, and I'll see you again for our lesson tomorrow.